Okay, welcome back to the Learning Lounge video. This one we're going to be going over probability and just like not normal curves and stuff, but the probability from Venn diagrams and trees and tables and stuff with the different formulas that you're going to have to know. So what are we going to be going over? We're going to be going over, one, the formula that for this specific question, the general formula for it. And then we're also going to be going over how to find it from a Venn diagram and from a table. So, the general formula, we have first, you have to talk about the common symbols that we're going to use. So you have this little thing that looks like a U, and this symbolizes it's either going to mean or it's going to mean that you're adding something together. So it could be like, what is the probability of something being a cat or a dog, right? If that was the question, and that's what you would use. So you'd have the probability of cat, you, dog. And that's basically signifying that you're going to be adding the probability of being a cat to the probability of being a dog. And then the other symbol that's commonly used in this is this little thing that looks like an N, and that means multiplying so what would the probability of being, I don't know, like over 25 and you have a master's degree, right? If that was the problem, then you'd have probability of master's and over 25 or something. Or you see it in the Venn diagram when the two columns are overlapping, so the middle section. And then in a table, it's when it's the box, basically, that it's in, because the table's showing, the box it's in is showing what, like, probability stuff it fits. So they're used in notation to find probability from tables, Venn diagrams, trees, and models. So they give you your little symbol notation that you're going to write on your paper to then just plug in the numbers to. And so the question for this one was this formula here, so the probability of A or B, right? And so the formula that you're going to get on the formula sheet for it shows that you do the probability of A plus probability of B minus probability of A and B, because if you added them both together, you'd be counting them both twice, so you have to subtract one of them. So it's asking for the probability of A or B. That's just explaining how you have to subtract. But there's an easier way to do this than using just this formula, which we're going to be going over in the examples. So, in an example, this one is from a Venn diagram. Say we were given these values, right? So you have the probability of A, B, both, and then there's neither. So, that's what you'd see. So our question would be the probability of A or B in this. So instead of doing all of A and then all of B and then having to subtract the middle 0.24 value, what we're going to do instead is you just add each one individually. So 0.47 plus 0.24 plus 0.25, and that gets you 0.96. Or these ones, like for just figuring out how, like the number, you could just look, well, it's going to be everything except what's neither A or B, which is 0.04. So you could just do 1 minus that. But for notation on your paper, you have to show where you're getting the numbers from. And so we don't have to subtract the middle because we didn't count it twice. But if we'd used the formula, so if we did instead all of A, which would be 0.47 plus 0.24, so 0.71, and then all of B, which would be 0.49, you'd have to add those together and then subtract 0.24, which is, in my opinion, it's more complicated, and I know Miss Queen teaches it's more complicated, so it's just easier to write all the numbers and not have to worry about, oh, what if I forgot to subtract, or what if I accidentally subtracted twice because I thought I forgot to subtract. And then, so our other example is from a table. So if we were given this table, I don't know what it is, but these are the probability of something being old or new, and let's say it's someone having a new phone and them responding to a questionnaire or something. These were the probabilities. And then if we were looking for the probability of somebody having a new phone or saying no, then we would have to go with all the probabilities of them having a new phone, which is 0.35 plus 0.3, and then all the probability of them saying no, right, which is 0.3 and 0.15, but we already counted the 0.3 in the new, and so that's the overlap section, right? That's the one that we would, if we were doing it by the formula, we'd have to subtract that. But since we can see we already counted it once, you would just add that 0.15, so you don't have to worry about subtracting. And you get 0.8, and then this one, again, we don't have to use the formula. We can just look at it and figure out which ones we're looking for to include.